Okay, at this problem, I'm just going to find the direction of the electric field at point P. In another tutorial, I talk about how to find the actual size. Here, I'm much more interested in the direction. Both charges are creating an electric field that spreads out throughout all space. So I could calculate the electric field for this plus Q charge in any location. Likewise, I could do it for the negative charge at any location. But here I'm looking at a point P that is on the axis that bisects the line that connects the two charges. We're going to use the principle of superposition, which we use a lot, and the electric field at point P is simply going to be the sum of the individual electric fields. Because they're vectors, we will have to pay attention to the direction that they point. And that's the interesting thing about this particular problem. Okay, so let's start with the positive Q charge here. We know that the electric field is going to have to point along a line that connects the center. And so we'll draw that in green here. So the electric field is going to be along this line. And because this is a positive charge, the electric field will point away from the charge. I don't know the size of that, or I can easily calculate it, but that's not the point of this. Let's do the same thing for the negative charge. So once again, it's going to be on this line that connects the 2 points. Now because this is plus Q and this is minus Q, these are the same size charge. I've designed it so that they're the same distance from to point P, and so this will be exactly the same length as this, pointed in the opposite direction. So this is pointing down into the right, this is pointing down into the left. So what will the electric field be? It's going to be the vector sum of these two guys. So because I'm a little bit crazy, I'm going to use this to sketch out the sides of a parallelogram. All right, and so the final electric field is going to be this big. If I had to calculate it, I would use the vertical component of this and the vertical component of this, which are the same size. So basically, if I find the vertical component of this and multiply by 2, I get this. Okay.